So this is question 16. The question states the order is the prescriber orders a cardiac stimulant dopamine chloride at a rate of 3 micrograms per kilo per minute. The patient weighs 125 pounds. A solution of dopamine hydrochloride is available in 100 milligrams and 125 mils of D5W. D5W stands for 5% dextrose in water. How many micrograms per minute will the patient receive, and how many milliliters per hour will the patient receive? So the first thing that we're going to do is focus on the order of 3 micrograms per kilogram per minute. Now, the patient's weight is given to us in pounds, so the first thing that we want to do is convert pounds into kilograms. So 125 pounds is going to be multiplied by our unit fraction of 1 kilogram is equal to 2.2 pounds. And that gives us roughly 56.81 kilograms. Now, that 81 repeats, so please do not clear your calculator. Please keep all decimal places until the very end. Just for the sake of space, I'm only going to keep 2 decimal places here, but your calculator should have 8181 repeating. Okay, so now that we know that the patient is approximately 56.81 kilograms, we're going to determine how many micrograms of this drug this person is going to receive. So we're going to take that order of 3 micrograms per kilo per minute and multiply it by what this patient weighs in kilos to determine how many micrograms of dopamine hydrochloride they will receive. So now I'm going to take what we've just converted, which was our 0.17 milligrams per minute, and I'm going to multiply that by that strength that was given to us. So notice that my milliliters, 125 milliliters, is on the top and my milligrams is on the bottom, and that's because I want the milligrams to cancel out. So when we multiply this through, we get 21.3068 milliliters over 100 minutes. And that's great. We want milliliters on the top. We want time on the bottom, but right now our time on the bottom is in minutes, and that's not what we want. We want it to be in hours. That's not a problem. All we're going to do now is multiply 21.30618 milliliters over 100 minutes by our unit fraction of 60 minutes over 1 hour. So that way the minutes cancel out, and we're left with a denominator of hours. So when we multiply 21.3068 by 60, we end up with 1278.408 milliliters over 100 hours. And so now I'm just going to reduce down because the question wants it per hour, not per 100 hours. And that leaves us with an answer of 12.78 milliliters per hour. Now, because it's a flow rate and we're dealing with mils, you cannot really have 78 hundredths of a milliliter. It's just not possible in an IV drip or even a push. So we would actually round out to be approximate. So approximately 13 mils an hour is what that patient would receive. For the purposes of the test, I'm fine with you leaving it at 12.78 milliliters per hour because it's really the math that we're concerned about here. So this patient would receive 13 milliliters per hour of this cardiac stimulant.